Hello students, in previous sessions we have done derivatives of different types of functions, explicit functions, implicit functions, inverse trigonometric functions, exponential functions, logarithmic functions. Now we are going to see the derivatives of parametric functions. Okay? So if you look at this derivatives of functions in parametric forms, a relation expressed between two variables x and y in the form of x is equal to f of t, y is equal to g of t is said to be parametric form with t is a parameter. Okay? So a relation between x and y, that means between two variables, the relation you can express in this format. Suppose for example, if I take x square plus y square is equal to 1. So we have this relation, but we will express this relation in a different way. X is equal to something cos t and y is equal to sin t. Okay? So we are expressing this relation x and y between x and y as x equal to cos t, y is equal to sin t by using another variable t. We call t is the parameter here. Okay? So with the help of another variable we are expressing the relation among this x, y. Okay. So this type of functions we call it is parametric forms of the functions. Now how to find out the derivative of this kind of functions? Now you can see that y is a function of t and x is also function of t. When x is a function of t, then you can find out rate of change of y with respect to t. You can find out dy by dt, right? And then same way you can find out x is a function of t, so that's why you can find out dx by dt, right? So that's why by using chain rule we have this dy by dt is equal to dy by dx into dx by dt. By chain rule we can write like this. See that this dx get cancels, it will balance with this dy by dt. So that's why from this dx by dt you just bring it this side, so you are getting dy by dx here. So dy by dx is what now? Dy by dt divided by dx by dt whenever this dx by dt is not equal to 0. dx by dt not equal to 0. Okay. So or otherwise, in other words you can write, because y is a function of g of t we wrote here, instead of dy by dt you can write g dash of t, and dx by dt if you see you can write it as this one f dash of t, because x is a function of t we wrote, right? Are you clear? So whenever parametric functions given, that means the relation between x and y given by another variable, okay, some other third variable we are using and we are expressing it. So for example, I have given it's one of the simplest example, x square plus y square equal to 1. It is a relation between x and y, but we are not expressing like that, but we are writing x equal to cos t, y is equal to sin t. So that what happens, it is cos square t plus sin square t, it become 1 here, right? Have you understood what is the parametric functions and how we differentiate them? Okay. So parametric functions means relation between x and y will be expressed by another variable. Okay. So by using third variable, right? And then how we can find out derivative means by using chain rule we can write dy by dx is dy by dt divided by dx by dt. It may be sometimes the third variable in different problems, different variable they use. Okay. Here parametric in t it is. Okay. Some problems they will write in parametric in theta. Okay. Instead of this t I can write theta also. X is cos theta, y is sin theta. Okay. You can write some other also, alpha. Okay. So here by using another variable, it may be t, it may be theta, it may be alpha, it may be beta, whatever it is. Okay. So this is the way we have to work it out and we have to get the derivative of it. Okay. So we will work it out, problems based on this. Just it's a very simple thing, you need to work it out in which parameter it is present. Okay. You have to see that, and then with respect to that you have to differentiate it. If it is present in theta, you have to differentiate with respect to theta. So you will get dx by d theta and dy by d theta. right? If it is in terms of t, then you have to do dx by dt and dy by dt. So that we can find out dy by dx. Okay, you just remember this formula, right? So now we are going to solve the problems. Dy by dx, find dy by dx if x is equal to 80 square comma y is equal to 280. X equal to 80 square comma y is equal to 280. Now the relation between x and y expressed in terms of t it is. So t is the parameter in this place. So that means you need to differentiate with respect to t now. So given x is equal to 80 square, y is equal to 280. Differentiate with respect to t on both the sides. On both the sides. So what do you get? Dx by dt is equal to a is a constant, a into d by dt of t square. Okay. So it is like d by dx of x power n. What is d by dx of x power n? N into x power n minus 1. So therefore dx by dt is equal to a into differentiation of t square with respect to t. So you are getting 2t here, 280 dx by dt, you are getting 280, and in this place here dy by dt is equal to, you are doing with respect to t now. So dy by dt is equal to 2a is a constant, so you can express it outside, 2a into dt by d by dt of t it is. So its value is 1 it is. So dy by dt is equal to 2a into 1 it is. It's just like d by dx of x 1. So dy by dt is 2a now. So now you need to find out dy by dx. So what is dy by dx? Dy by dx is nothing but dy by dt divided by dx by dt. So what is dy by dt? 2a divided by dx by dt is 280. Now this 2a get cancels, we will be getting 1 by t. So this will be the answer for this. So dy by dx is 1 by t. Okay, right? But many of the students will do mistake in this place. You know, they will write this by this, because first this is there, that is why they will write 280 by 2a. Okay, because this by this, it is a like habituation. So what you have to do, carefully you see that dy by dt you are writing first here in the numerator 2a divided by denominator is dx by dt. So 280. So 1 by t will get the answer. We will see another problem. Find dy by dx. Find dy by dx if x is equal to a cos theta comma y is equal to a sin theta. X equal to a cos theta comma y is equal to a sin theta. You can see that the relation between x and y they have given in terms of theta now. In terms of theta. So you have to differentiate with respect to theta now. So given thing, given x is equal to a cos theta comma y is equal to a sin theta. So differentiate with respect to theta on both the sides. On both the sides. What happens? So dx by d theta, d by d theta of x is dx by d theta is equal to a is a fixed value, constant, you can write outside, d by d theta of cos theta. Okay. So what you are getting, dx by d theta is equal to theta into differentiation of cos theta is minus sin theta. So you are getting dx by d theta is what? Minus theta sin theta. So the same way on this one, y is equal to a sin theta, differentiate with respect to theta now. So d by d theta of y. So d by d theta of y is dy by d theta is equal to A is a fixed value into d by d theta of sin theta. So, dy by d theta is equal to A into differentiation of sin theta is cos theta, because you are doing with respect to theta only, with the same variable you are doing. So, you are getting dy by d theta is A cos theta. So, therefore, dy by dx is equal to, here it is in terms of theta, no? So, that is why you have to write dy by d theta divided by dx by d theta. So, which is equal to dy by d theta, what we get? A cos theta divided by minus, sorry, here this is minus A sin theta, not theta, it is A. So, divided by minus A sin theta. Okay. So, what happens here? A get cancels, A get cancels. So, what we are getting? Minus cot theta we will get, minus cot theta, right. So, I think you might have understand clearly now how we can do this, right. Whenever it is in terms of t, parametric in terms of t, then you differentiate with respect to t on both sides. Whenever the parametric function is in terms of theta, then you have to differentiate with respect to theta and you have to work it out. Okay. Right, we will see another problem. If x is equal to A into theta plus sin theta, x equal to A into theta plus sin theta, and y is equal to A into 1 minus cos theta, y is equal to A into 1 minus cos theta. Prove that dy by dx is equal to tan theta by 2. dy by dx equal to tan theta by 2. We have to prove this one. So, here x and y, they are in terms of theta now. That means parametric in theta. So, that means you have to differentiate with respect to theta here. So, given things you write first, given x is equal to A into theta plus sin theta. Okay. So, y is equal to A into 1 minus cos theta. Now, differentiate with respect to theta on both the sides. Differentiate with respect to theta on both the sides. Okay. So, when you differentiate with respect to theta on both the sides, d by d theta of x, d by d theta of x is equal to, A is a fixed value, A into d by d theta of theta plus sin theta. Okay. So, dx by d theta is equal to A into differentiation of theta with respect to theta is 1. It's just like d by dx of x is 1 plus d by d theta of sin theta. So, d by d theta of sin theta is cos theta. Okay. Next, this side here, d by d theta of y is equal to, A is a fixed value into d by d theta of 1 minus cos theta. Okay. So, dy by d theta is equal to A, the constant A, into differentiation of 1 is, differentiation of constant is always 0. Okay. Minus differentiation of cos theta is minus sin theta. d by d theta of cos theta is minus sin theta. So, what you are getting now? dy by d theta is equal to A sin theta. Okay. So, we got dy by d theta and as well as we got dx by d theta. So, now therefore, dy by dx is equal to dy by d theta divided by dx by d theta. So, what is dy by d theta? We got it A sin theta, this is, divided by this one A into 1 plus cos theta. A get cancels. Then sin theta means you can write by a half angle formula from trigonometry. Sin theta means 2 sin theta by 2 cos theta by 2. From trigonometry, we have this formula, half angle formula. 2 sin theta by 2 cos theta by 2. 1 plus cos theta. 1 plus cos theta is 2 cos square theta by 2. Okay. So, one of the 2 to get cancels and 1 cos get cancels. Right. So, what is remaining now? So, remaining thing is sin theta by 2 divided by cos theta by 2. So, which is equal to tan theta by 2. This is the thing they asked us to prove. Right. We got it. So, dy by dx is tan theta by 2. Right. So, hope you understand this. Right. So, we will go for the next one. Find dy by dx. Find dy by dx if x is equal to a into cos t plus a into cos t plus log tan t by 2 log tan t by 2 y is equal to a sin t. Find dy by dx if x is equal to a into cos t plus log tan by 2 tan t by 2 y is equal to a sin t. Right. So, we will take x because it is a little bit okay, 2 terms are there to differentiate. We consider just x first and then we do differentiate with respect to t now. Right. X is in terms of t and as well as y is also in terms of t here. So, we just consider this first and we work it out. It is one of the important question for a PU board. So, consider x is equal to a into cos t plus log tan t by 2. Okay. So, we just differentiate with respect to t, differentiate with respect to t on both the sides, Okay. Then d by dt of x is equal to a is a fixed constant a into d by dt of cos t plus d by dt of log tan t by 2. Okay. We just applied the derivative to each and every individual term there. So, what you are getting now, dx by dt is equal to a into d by dt of cos t. D by dt of cos t is minus sin t, right, because you are doing with respect to the same variable, right. So, cos t with respect to dt here now. So, minus sin t plus differentiation of log x. Differentiation of log x is 1 by x formula. So, 1 by tan t by 2 into d by dt of tan t by 2, d by dt of tan t by 2. What is d by dt of tan t by 2? D by dt of tan t by 2. Differentiation of tan x is secant square x. So, secant square t by 2. Again, it is not just a simple t, no, it's a t by 2 it is t by 2. So, its derivative you have to consider. So, once again I will tell you, listen carefully, this is in this place. Differentiation of log x is 1 by x, because it is not x, its derivative you have to consider again. So, d by dt of tan t by 2, d by dt of tan x is secant square x. So, secant square t by 2 into d by dt of, because it is not t, again its derivative you have to consider 1 by 2, right. So, next continuation, a into minus sin t plus 1 by tan t by 2, that meaning is cot t by 2, right. 1 by tan means cot means cos by sin. So, it become cos t by 2 divided by sin t by 2. You have to understand carefully, this is 1 by tan means cot means cos by sin into secant square t by 2, you can write as 1 by cos square t by 2 into 1 by 2. Now, one of the cos get cancels here, one of the cos get cancels. So, a into minus sin t plus 1 by 1 by, what is remaining now in the denominator? 2 sin t by 2 cos t by 2, right. So 2 sin t by 2 cos t by 2 is sin t. So a into minus sin t plus 1 by sin t we are getting. Still we simplify this. Sin t is the LCM. You take sin t as the LCM. What happens here? A into sin t is the LCM. So we get minus sin t into sin t. So minus sin square t we get. Minus sin square t plus 1. What is this from trigonometry formula? 1 minus sin square t. 1 minus sin square t. It become cos square t, right? 1 minus plus 1. 1 minus sin square t is cos square t divided by sin t. So a into 1 cos t will write first into again cos t by sin t. What is this cos t by sin t? Cot t. A cos t into cot t this is. So we got now dx by dt value. This is dx by dt. So we take it as 1. And then now we consider y value. Consider y is equal to a sin t. So then we differentiate with respect to t on both sides. Differentiate with respect to t on both the sides. So we get d by dt of y is equal to d by dt of a sin t. Okay. So dy by dt is equal to a into a is a fixed value, right? So we can treat it as constant, we can write because it's a coefficient of sin t. So d by dt of sin t is cos t. So we got a cos t now here. Okay, dy by dt is this, dx by dt. Now we want dy by dx. So finally, therefore, dy by dx is equal to, so what happens? Dy by dt divided by dx by dt. Okay, so dy by dt divided by dx by dt. So what is dy by dt? A cos t. So a cos t divided by dx by dt, what we got? A cos t into cot t. Okay, so a get cancels, cos t get cancels. So remaining is 1 by cot t is nothing but tan t this is. This is what we need to prove or we need to find out. Dy by dx is tan t we will get, right. It is one of the very important problem. So we will see one more of this same kind. Find dy by dx, find dy by dx. If x is equal to a into theta minus a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta. Okay. So this is another problem. We need to find dy by dx. If x equal to a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta. Same way we will consider 1x and then we differentiate with respect to what now? With respect to what we have to differentiate it, because here it is in terms of theta it is now. So that is why we differentiate with respect to theta on both the sides. So we consider x is equal to a into cos theta plus theta sin theta. Differentiate with respect to theta on both the sides. So d by d theta of x is equal to a is a coefficient for this entire variable. So, A into d by d theta of cos theta plus d by d theta of theta sin theta. Okay. So, now we are getting dx by d theta is equal to, you are doing with respect to theta here because it is in terms of theta, it is A into d by d theta of cos theta, formula is what? Minus sin theta plus here you have to apply UV formula. You have to apply UV formula in this place. So, U into differentiation of sin theta, d by d theta of sin theta is cos theta plus V into sin theta into differentiation of U, d by d theta of theta, you are getting 1 in this place. Okay. So, that means now what happened here? Dx by d theta is equal to A into minus sin theta plus theta cos theta plus sin theta. Now, this plus sin theta minus sin theta get cancelled. So, what is remaining finally? Dx by d theta is equal to A theta cos theta we are getting. So, we take it as 1. Similarly, we take y and we differentiate with respect to theta now. Okay. So, y is equal to A into sin theta minus theta cos theta. We consider this now and we differentiate with respect to theta. Differentiate with respect to theta on both the sides, Okay. Differentiate with respect to theta on both the sides. So, d by d theta of y is equal to, A is a fixed value, we can write outside, d by d theta of sin theta minus d by d theta of theta cos theta. Okay. So, to the individual terms we applied. So, dy by d theta is equal to A into d by d theta of sin theta is cos theta, right. So, differentiation of sin theta with respect to theta. So, cos theta minus UV formula you have to apply. UV when you are applying two terms we get, here minus is there. So, we should be careful. So, put the bracket U into differentiation of cos theta is minus sin theta plus cos theta into V into differentiation of U. So, differentiation of theta is 1. So, what we are getting when you release this minus A cos theta or otherwise let it be like that, A into cos theta minus of minus plus theta sin theta minus cos theta. When you release the bracket, this with the minus. Now, this cos theta minus cos theta get cancels. So, A into what is remaining? Theta sin theta. So, A theta sin theta is remaining. So, this is dy by d theta it is, dy by d theta. This is the second one. Okay. So, dx by d theta we got A theta cos theta, dy by d theta we got it A theta sin theta. So, now dy by dx, therefore, dy by dx is equal to dy by d theta divided by dx by d theta, right. So, what is dy by d theta? We got from condition 2 A theta sin theta divided by dx by d theta we got it A theta cos theta, A theta cos theta. So, A theta get cancelled, sin by cos, tan theta we got it. Okay. So, dy by dx is tan theta is the answer for that. Okay. So, I hope you got a good idea on how to differentiate the parametric functions. So, in this manner we have to work it out. Okay. So, this is a differentiation of parametric functions. Now we will go for successive differentiation. Start, sir. So we are going to see that second order derivative. So if I am having the function like this, y is equal to fx, then dy by dx is f dash of x, right? If again this f dash of x is differentiable, okay? If again f dash of x is differentiable, what we can do, one more time we can differentiate it. So that's why the left hand side we are differentiating with respect to x. So see that d by dx of dy by dx. So this one is called second order derivative of y with respect to x. And how we denote it? We denote it by d square y by dx square. D square y by dx square we denote it. Just one more time we are differentiating, that's it. So whenever it is differentiable. Now the second order derivative of fx is also denoted by like this, f double dash of x, okay? And we denote if y is equal to fx, we can denote like y double dash y2 d square y, capital D square y, like this. In three different ways you can denote the second order derivative. So if you go for higher order, that means one more time if you differentiate this one more time, then you will get third order derivative, that's it. If it is differentiable, if d square y by dx square is again differentiable, then what you can do, one more time you can differentiate it, then you will get d cube y by dx cube. See that if this is dy by dx now, it's called first order derivative. If this is differentiable, then what we are doing, one more time we are differentiating, that's it. So we are getting what this is, d square y by dx square, okay. If this is again differentiable, you can do one more time differentiation. So d square y by dx square, you are getting d cube y by dx cube, like this, right. So likewise we can define the higher order derivatives also. We will see the problems, it is not so difficult, you have to differentiate one more time, that's it, okay. So in the second order derivative we see that the problems how we can do it, right. We will see the problems. If y is equal to sine inverse x, if y is equal to sine inverse x, find d square y by dx square, find d square y by dx square. See that y is equal to sine inverse x. Just differentiate with respect to x on both sides. Differentiate with respect to x on both the sides. Okay. So what happens? D by dx of y is equal to d by dx of sine inverse x. Okay. So dy by dx is equal to d by dx of sine inverse x, you know, 1 by square root of 1 minus x square, 1 by square root of 1 minus x square. So once again you need to differentiate this one. So dy by dx is, you can write this is like this way, 1 minus x square whole power minus 1 by 2, because square root is there. If you write in the denominator 1 minus x square whole power 1 by 2. If you take it to the numerator, it becomes minus 1 by 2. Again you differentiate this one more time. Differentiate again, okay, again differentiate with respect to x on both the sides. So what happens? D by dx of dy by dx is equal to d by dx of d by dx of 1 minus x square whole power minus 1 by 2. Okay. So what it become? It become d square y by dx square, this one. Become d square y by dx square. So which is equal to, now you treat it as x power n, we use a chain rule now. So feel like x power n, what is x power n? N into minus 1 by 2 into n into x power n minus 1, n minus 1. Is it really x? Is it really x? No, we assumed as x and we proceeded, right? So it is not actually x. So its derivative you need to consider into d by dx of 1 minus x square. So what you are getting, minus 1 by 2 into 1 minus x square whole power minus 3 by 2 into differentiation of 1 constant is 0, d by dx of 1 is 0, minus differentiation of x square 2x. So this minus 1 by 2 into minus 2x here, minus 1 by 2 into minus 2x into this one 1 minus x square whole to the power of minus 3 by 2. Here what happens, this minus 2 get cancels, only x will remain, x into 1 minus x square whole power minus 3 by 2. This is what will remain finally. Okay. Sometimes they will ask find d square y by dx square only in terms of y. Okay. Just suppose they ask d square y by dx square in terms of y they ask. How we can write, how we can convert this answer into in terms of y? From this y is equal to sine inverse x. So what you can write, x equal to sine y, x equal to sine y you can write, just you can substitute there. Okay, this is over actually if they ask. Okay, so x you can substitute as sine y. Okay, x is sine y from here, y is equal to sine inverse x, no, that is why x equal to sine y. So sine y into 1 minus sine square y divided by minus 3 by 2. That means sine y into 1 minus sine square y is cos square y whole to the power of minus 3 by 2. That means this 2 and this 2 get cancels, right? X power m whole power n, x power mn. So sine y into cos y whole power minus 3. That means you can write it as sine y by cos cube y. So if you take one cos here, sine y by cos y is tan y into, still one more cos square is there in the denominator, right? One cos y we taken and sine y by cos y is tan y, still one more cos square y is there. So 1 by cos square y is secant square y. So like this we can show that the answer in terms of y if they ask, or otherwise we can leave it here, right? So we will continue for the next problem. Y is equal to 3 cos log x plus 4 sin log x, 4 sin log x. Prove that x square y2 plus xy1 plus y is equal to 0. So now onwards whatever we are doing, it's a 5 mark very important questions for the final examinations. It is also one of that kind. So 5 mark questions. Okay. So y is equal to, given y is equal to 3 cos of log x plus 4 sin log x. Just differentiate with respect to x on both the sides. Differentiate with respect to x on both the sides. Okay. So dy by dx is equal to 3 into differentiation of cos x. Differentiation of cos x is minus sin x minus sin x. Is it really x? No. Okay. So to apply the formula we have assumed as x and we applied. So minus sin x into, again d by dx of log x. We have to consider d by dx of log x is 1 by x plus 4 into differentiation of sin x is cos x. So cos of log x into, because it is not x, its derivative you need to consider, right? So d by dx of log x is 1 by x. So what you are getting now, dy by dx is nothing but y1. Dy by dx is nothing but y1 it is. So y1 is equal to what you are getting here, minus 1 by x into minus 3 sin log x, because minus is there now. So minus 3 sin log x, this 1 by x taken out common, plus 4 cos log x. we got this one, right. Now, what I do is, you bring this x this side, xy1, we just bring this x this side here. So, what I get now, xy1 is equal to minus 3 sine of log x plus 4 cos of log x. Okay. So, we got like that. Now, again we differentiate with respect to x on both sides, because we need y2 also. y2 means d square y by dx square, y1 means dy by dx. Now, again differentiate with respect to x on both the sides. So, what happens? D by dx of xy1 is equal to minus 3 into d by dx of sine of log x plus 4 into d by dx of cos of log x. Okay, right? So, we just applied derivative once again. UV formula you apply here. See, y1 means it is dy by dx. y1 means dy by dx. So, UV formula, u means x into d by dx of y1 plus y1 into product rule we are using, y1 into d by dx of x is equal to minus 3 into, what is d by dx of sin x? Chain rule we are applying. D by dx of sin x is cos x. Is it really x? No. So, its derivative you need to consider. So, d by dx of log x plus 4 into d by dx of cos x is minus sin x minus sin log x into, because it is not x now, its derivative you have to consider. So, d by dx of log x. Now, what we are getting? D by dx of y1 means d by dx of dy by dx. This is nothing but d square y by dx square, nothing but y2 this is. So, which implies what we are getting? X into y2 plus y1, because the differentiation of x is 1 here, is equal to what we are getting? Minus 3 cos of log x into 1 by x because d by dx of log x is 1 by x, minus 4 sin log x into d by dx of log x is 1 by x. Now, you take 1 by x common or minus 1 by x take common on other side, x into y2 plus y1 is equal to 1 by x when you take common, minus 3 cos log x, minus also we take common. So, minus 1 by x, 3 cos log x plus 4 sin log x. You just observe 3 cos log x plus 4 sin log x is what? Y it is. We name it as 1, okay, and we substitute this y value there, okay. So, which implies x into y2 plus y1 is equal to minus 1 by x into y from 1. That means the given thing it is from 1. So, you cross multiply this x this side. So, what you are getting? X square y2 plus xy1, right, is equal to minus y. We just cross multiplied this x. When x comes, this division comes multiplication. So, x into x square y2, x y1 is equal to minus y. Bring that minus y this side. So, you are getting therefore x square y2 plus xy1 plus y is equal to 0. This is what we need to prove it, right. So, x square y2 plus xy1 plus y, we got it. So y1 means dy by dx, y2 means d square y by dx square, right. So we will see another problem of the same kind. If y is equal to 3 e power 2x plus 2 e power 3x, then prove that d square y by dx square minus 5 dy by dx plus 6y equal to 0. So we will see that the given thing, solution, y is equal to 3 e power 2x plus 2 e power 3x. This is the given thing. So differentiate with respect to x on both sides, on both the sides. What happens now? So d by dx of y is equal to 3 into d by dx of e power 2x plus 2 into d by dx of e power 3x. Here you are getting dy by dx is equal to 3 into e power x, differentiation of e power x, chain rule you have to apply. You assume as x whatever it is present. We have formula e power x. So d by dx of e power x is e power x, but it is not x, no. So its derivative you need to consider 2x plus 2 into differentiation of e power x is e power x, but this is not x, no. So its derivative you need to consider. So d by dx of 3x, that is a chain rule, right. So dy by dx is equal to 3 e power 2x into differentiation of 2x is 2 with respect to x we are doing. So that is why dx by dx 1 it is, plus 2 into e power 3x into 3 this is. That means what you are getting now. So dy by dx is equal to 6 e power 2x plus 6 e power 3x we are getting. This is dy by dx value. Now again we differentiate and we get d square y by dx square value. We have taken this is 1 and this is 2. Now again we differentiate this one. Again differentiate with respect to x on both the sides. What happens? So d by dx of dy by dx is equal to 6 is a constant. So d by dx of e power 2x plus 6 into d by dx of e power 3x, right. Now it becomes d square y by dx square, 6 into differentiation of e power x is e power x, but this is not x, no, its derivative you need to consider. Differentiation of 2x is 2, I am writing directly, plus 6 into differentiation of e power 3x is e power 3x into differentiation of 3x is 3. So what we are getting, d square y by dx square value 12 e power 2x plus 18 e power 3x. This is a condition 3 we take it. Now all these things we got y value, we got dy by dx value, we got d square y by dx square value. We just consider this. LHS we consider. So LHS is what now? D square y by dx square minus 5 into dy by dx plus 6y. We need to prove that this entire value is 0. This is one of the method you can do, finding dy by dx, d square y by dx and substitution. So previous problem what we have done is like cross multiplied and differentiated, directly we got it, okay. So here we are doing by substitution method here. D square y by dx square, what is it? From 3, 12 e power 2x plus 18 e power 3x minus 5 times of dy by dx. That means dy by dx is here, dy by dx is here. 5 times of this, okay. So 5 into 6 e power 2x plus 6 e power 3x. This is a dy by dx value, and plus 6 into y. Y means the given one. So y value is what? 3 times of e power 2x plus 2 times of e power 3x. This is y. From condition 1 it is. 3 e power 2x plus 2 e power 3x. Now simplify 12 e power 2x plus 18 e power 3x minus 30 e power 2x minus 30 e power 3x plus 18 e power 2x plus 12 e power 3x. Now see that 12 e power 2x, okay, and 18 e power 2x. 12 e power 2x, 18 e power 2x. So it becomes 30 e power 2x. With this it get cancels, right? So all these things get cancelled. Next here 18 e power 3x and this one 18 e power 3x, 12 e power 3x together 30 e power 3x and here minus 30 e power 3x is there. So everything get cancelled. Okay, for your understanding sake I kept the symbols. See these three together cancel 0 and these three together get cancelled and get 0. So finally what you are getting it is, the answer is 0. So 30 e power 2x minus 30 e power 2x plus 30 e power 3x minus 30 e power 3x we are getting. So finally the answer is 0. So which is the RHS. We need to prove this one only. Okay, right?